So we are going to talk about the global deployments and adoption rates in Open RAN around the globe. Um, I am here located in Mexico, the local time, so it's 2 a.m. around here. So I would like to start with this presentation. These are our main topics, and so you can make the question according to the program, I think at the end of this session. So anyway, if you have any questions, just put it in the chat, in the Q&A chat box. When we talk about Open RAN, is something that has started like several years ago, like with this in particular, like organization like the ORAN Alliance, with the merging of two teams, the C-RAN Alliance and the X-RAN Alliance, like a few years ago. I considered like this Open RAN like a game-changing technology that has like a main mission like disrupt the telecommunication industry, offering a more open and flexible architecture. This ORAN Alliance is leading the charge, promoting and developing Open RAN standard for the radio access network architecture by moving or putting together like components from several vendors. They are creating a more agile, scalable, and interoperable ecosystem for 5G networks. I would like to start first with these basic concepts in our RAN architecture. As you know, in RAN, we have like this stack that I think you have seen a lot in all the activities related with RAN and Open RAN. So we have like the two main components, like we have here, like from one side, we have here the core. The core, we have like these two main parts that are the user plane function that allows the connection to the data network. And also we have this access and mobility management function that is in particular focused on all of this control signaling from the user to the node and also to the packet core. So when we have all of these, in particular for 5G, we have all of these stacks for the control plane, for the user plane and also for the control plane. So this allow us like the communication and to allow us the connection between the user equipment, the core, and also to the network, to the data network part. So we have like this different stack, and the importance of this stack in particular for RAN and in particular for Open RAN is the possibility to split this part and assign all of this part to different components in our RAN or in our G node B for 5G. So we have like this part that is this stack, and we can see here in this part on the right, like what was the division of the RAN part or the RAN side in the traditional way when we have like 2G, 3G, and 4G. In particular, we have like these two main parts, the baseband part and the RU parts, connected here by backhaul to the core, and this front haul connecting the baseband unit to the RU. Here, I think one of the most important or the most interesting standard from the 3GPP is these numbers. The 3GPP TR38801, because they define the functional split for 5G RAN architecture. And this functional split using all of this stack allow us like divide this, let's gonna say this traditional baseband like in two main components called the CU and the DU, connected by something called mid-haul. So this one, let's gonna say, is coming from the 3GPP standard or specification, is used by the traditional G node B, and it's also used by the Open RAN site using the specification from Open RAN that we will see like in the following slides. So the thing here, I think the most important here to remember is this specification, TR38801, that you can check in the internet and you will see like the complete details about how is this split and how the split is working in general. So when you have using that stack in particular, and also this another specification called this specification, the 38913, that I think is like for me, like the two more important specification, is they show like the different deployment scenario for all of these sites that we have. We have sites that could be used in indoor hotspots, like for example, inside a building. We have like this possibility for dense urban areas that we have like in our main important city, like for example, in Manila or here in Mexico City. Also, we have the possibility, like a particular scenario that is called for rural, because for rural, you need to cover like more wide area here. You have urban macro that difference from dense urban. In urban macro, you use like low frequency to cover more area inside a urban area. You have high speed scenario that I think also are very interesting, that will also have a specification to cover this particular scenario in 5G, that you have train that is moving like really fast. So you can have like these sites covering like this fast train moving around all of this cell. So you need like a very fast handover that can handle this handover between the different cell. So you can have like a complete coverage in all the track for this train. Also for this scenario, like one of these 12 scenario is this extreme long range area, because difference to the rural area that maybe you have like a covered like 15 maybe 15 kilometers or 20 kilometers. In this extreme long range, you can have like areas covering between almost until 150 and 300 kilometers areas. So you can have like a complete area. In particular, is for these rural areas where you have like houses located like separated between them like maybe 1 kilometers or 5 kilometers. But also you can have just one site covering all of this long area around there. Uh, Also, you have like this urban coverage, as we can see here. Like you have you want to particular to have like different IoT devices or massive machine type communication devices located in around the city, like for example in sensors, in traffic lights, in all of these kind of devices located here. So you have like this urban coverage focus on this to cover or to cover these massive machine type devices. There is this scenario that we can see here is for highway scenarios where you have like vehicles moving not as fast as a train, but you have cars moving here, but you have to cover like particular long lines. So you have like sites focus on these lines. I mean, you don't have coverage around in the like here on the out of the highway, but you have coverage ensuring that you have the complete communication in all of these communication areas in the highway. Also, you have like this urban grid for cars that is particular focus on the V2X communication, where you have these vehicles with all the sensors and all the communication communicating with other cars, with people, with devices, with the traffic lights. The air-to-ground communication, for example, when you have like these airplanes and you have like this base station located here and also some repeated located inside, for example, an airplane to covering like this airplane inside the airplane. There's particular scenario that is for light aircraft. The difference to the air-to-ground communication in this light aircraft is a small aircraft, like a small airplanes here, and also to low altitude. So you have like this scenario. And one of the things that we are using right now is the satellite to terrestrial, like these non-terrestrial networks that you use this satellite to make the coverage to the ground, but using this satellite in the sky, that you have like these different levels of communication or coverage. And also there is one that is not directly reflected here, that is the UAV, that unmanned aerial vehicles. that you have like these small airplanes that have inside that have inside like this BTS, and also offering the communication to the ground from the airplane flying like a very low altitude, uh, covering like big areas. It's not as high as the satellite. It's a little bit low, but also can provide communication to the ground. The interesting here from this slide is to know like all of this scenario to provide like this coverage, like in the ground, and also from the ground to the air to these airplanes flying all around. In these slides, I want to show a little bit like the four most typical configuration for RAN, because we know for RAN we have like this kind of traditional RAN configuration that we also have from, let's gonna say, from 2G to the 4G actual, that you have a purpose bit RAN, where you have a hardware that was created and to provide RAN services. Is like what we have from the, let's gonna say, from the traditional providers, like from Ericsson, Nokia, Huawei, ZTE, and all of those providers, that they prepare like this very specific hardware to have all of this specific software to provide this traditional service in RAN. So you have like this hardware that have everything inside or specific for this RAN. They have like this transmission to the core using the backhaul to the backhaul transmission to communicate to the core. You have this front haul, or the communication between the baseband to the RRU to the antenna. The interesting thing is that we have using the, like the previous slide, what we have all of this stack separation, is you can start using all of these technologies. You can start using this 38801 specification, and you can have like this different type of special configuration for RAN for, let's gonna say, for from the 3GPP side, and also available in the Open RAN. So you have first the virtual RAN, where you are using like a particular hardware codes or a generic server, like a computer server. And over there, you have this software. You have it like this disaggregation, because you are separating from one side the hardware, like a general purpose hardware, like it's generic called codes, and you have a specific software for this. So you can separate, or you can have, for example, software from, let's gonna say, Samsung, Nokia, or Ericsson, or whatever, running in a general server, like a server, let's gonna say, from HP, from Dell, or from any providers, and having all of this RAN software. So we have like this vRAN. The interesting thing for this vRAN is also you can have like this split. I mean, you can have this separation, and you can have some software called distributed in one unit called distributed unit. You can have some other software of the stack that we saw in the previous slide located in the central unit. And you have now like a new connection that is called the mid-haul connecting the DU and the CU. So if we go a little bit further, we have something called Cloud RAN. Before, we have something called virtualized RAN, because we are using the virtualized principles. And right now we have the Cloud RAN, because we're using the Cloud RAN. The Cloud RAN, the interesting, as the name mentioned, is we have you are using the cloudified principle. We have from one side also, we have this distribution, or this segregation, because between software and hardware. And you have something called the cloudified ecosystem. You have some software using cloud or cloudified principles that allows you to put or to use this RAN software in the cloud, in something, in a particular containers in the cloud. And this containerization from, let's gonna say, also from different providers, you can also have this split version. So you have so far like three main configuration for run. We have something called from traditional run, the purpose-built run, the virtualized run, where you have like like this code server running software using the virtualized run, and also we have now the cloud run principles, deploying the software, the run software in a cloud environment, allowing this ecosystem, this software, this run working on this cloud ecosystem. So let's gonna say the most interesting so far now for me in this moment is the Open Run, because using this, let's gonna say this virtualized run, when we have the software separated from the hardware, is we have this Open Run that is, as the name mentioned, is using the Open Run principle. So we are using a virtualized ecosystem, and we have this open connection between the site, the core, and the core. This mid-hole open also between the units, between the ODU and the OCU units, and also you have the open front hole. The interesting thing about this Open Run is we can have like the so-called mix and match. I mean, you can have different providers playing in this area. I mean, you can have one player working on the hardware, one player working on the software, and also in the ORU units. So we are focusing here on having a very flexible ecosystem. So we can mix and match like different players here, like from different providers, that they are specialized maybe for the hardware, or they are specialized, for example, in the software. And so we can have it like this, a specification of this separation of OCU and ODU also on the cloud ecosystem, distributed or installed in different places. As we can see here, we have traditional run, we have virtualized run, we have cloud run, and also we have Open Run. As we see here, the Open Run, we can see, I think we finished all this academic stuff about what is a little bit what is Open Run. And here we go on this ORAN Alliance page, where we can see like how has been this deployment about Open Run around the world. So if you check here in this web page, anyway, you can just check ORAN Alliance, and you go to this map here. You can see like all the details about what is the actual status of the Open Run in all around the world. What is testing, what is the commercial deployment all around the world. I think so far here in our country, in Mexico, so far there are some testing around here, but it has not been reported. And in Philippines, I think we don't have like so far like a commercial. There are some testing that anyway, Mr. Matias can talk about that later if you wanna about that. So here is just to reflect a little bit how is the Open Run ecosystem working right now in the world. So just check here in this link here, that anyway this information will be available in the recording of this session. And so you can have like a general overview about what is RAN doing all around the world. So what's happening around the world in this commercial? After we see like that map around the world, we have like different players doing around the world in relation to this Open Run. Is, as you can see here, the Open Run is progressing, but it's taking some time, I mean, to reach like the values that we have right now with the traditional run. But anyway, more and more operators are implementing either a trial or are deploying commercial solution for Open Run. So as you can see here, we have like these greenfield operators like Rakuten Mobile that has launched 4G and 5G commercial service based on Open Run. There are also commercial deployments from, for example, from AT&T and Dish Network in the USA, working on 5G and Open RAN that we will see some slides later. There are also the possibility to have this Open RAN working on these rural and private networks. So it's deploying worldwide in this particular particular scenarios. We have um, some particular deployments that also focus that also evaluating super operators in the world is about sharing these Open RAN sites for different players in like in one country or in one area. Because the thing is, as we saw in the previous slide, this Open RAN is working on a virtualized and RAN ecosystem. So it's possible to also share this between different operators in one area. So you just install one site, and that one site can be deployed, can be shared between 1, 2, or 3 operators, and can offer a coverage. So in that way, for example, in rural areas where it's very difficult or very expensive to deploy a solution, so one is responsible for deploying this hardware, and they share the operation between different operators, so they can have different operators having services in that area. Also, this operator, Etisalat and STC, a Saudi telecom company, they are also testing, evaluating, and deploying Open RAN in their areas. There is also very interesting about the agreement, as you can see here, between Vodafone, Telefonica, Deutsche Telekom, Orange, and Telecom. They have signed a memorandum of understanding to support the Open RAN rollout in different areas in Europe. Also, the Telefonica, as they have operation here in, for example, in Latin America, they are also implementing some trials and some commercial deployment for in particular in Peru, offering this in Peru, and in particular in that rural areas in Peru, using Open RAN to offer services. So there is this compromise between this operator or these big operators around the world to support Open RAN. For sure, today there are several interesting deployment of Open RAN around the world, but I think these are like two emblematics deployments. One of them is Rakuten, and the other one is Dish, that I think you have heard a lot about what they are doing. So as you see here, in the traditional, let's not say in the traditional scenarios, we have like this operation of the core as you have here, with all the functionalities. We have in the edge some deployments using the DU and the CU parts of the sites, and in the particular side, you have like these deployments of RU, or radio frequency units, to provide the coverage on that area. So the interesting thing about Rakuten with the Rakuten is they try to focus, or let's not say growing, for this concept from different players, like for example from Huawei, Ericsson, and Nokia, and using this specification from open and virtualization, using the cloud, in this case the cloud provided by Rakuten by themselves, supporting from having the support from, for example, from NEC or from Altiostar, is to put in all of this in a cloudified scenario. So all of these functions that were before using a virtualized principle, right now are based on a cloudified principle, using all of these function, like these functions for slicing, for policy and control function, for mobility functions, for session, and all of that. Functions for make and user plane functionalities in a code server, all in a regional cloud, and also in the edge cloud. All of these RAN function, like the CU and the DU, deploying Open Run or using the Open Run specification to deploy like different kind of different sites all around the country in Japan, becoming one of the first deployment for Open Run. And the other one is a dish. Just comparing between the previous one that is using a Rakuten own cloud, a cloud developed by themselves with the support with different players. Here, the interesting thing for this is they are using like the hyperscaler from a third party. You can see here that they are using the AWS, the Amazon Web Service cloud, using to deploy this scenario for cloud. So they are using this cloud hyperscaler from AWS, this working on this ecosystem to deploy all of this core functionality, as you can see here from Nokia, in the local areas, having all of these let's gonna say BTS functionalities with the CU and the DU deployed in AWS solution. So they use the cloud to deploy this to deploy these core functionalities here in the cloud in the core, and also they use this ecosystem of work for AWS for deploying these BTS functionalities, the CU and the DU, more close to the end user, also using the all-run principle based, for example, from providers like Fujitsu and MTI. So what I want to show here is possible from the players when they are working with this all-run that they can grow from the existing networks using a cloud ecosystem that what most like several players are doing today, to deploy the all-run solution using a private cloud, as you see here, using a public cloud as here with the AWS, or also possible to using a mixed solution between public and private that is called a hybrid solution to deploy to have all of these 5G solution or also 4G solution. So here in this following slide, we can see a little bit what is the industry trend and prediction about all of these all-run deployments around the world. So today, as we can see in the news, there are players, there are telecommunication players all around the world deploying a different solution for Open RAN. So we can see the industry trends about this. The adoption of 5G and virtualization that is motivating or that is promoting a lot the growing of the 5G networks all around the world. There are different vendors that are promoting this diversity and interoperability of using this standard. So there is or using this principle of Open RAN from the, let's say, from the a traditional one vendor or two vendor per country to several vendors in the countries using the mix and match that you have heard about, mixing different players in the RAN, hardware, software, and different applications like the XApp and RApps that you have seen in the Open RAN ecosystem. Different features included over there that allow the automatization, the edge implementation, and the security. So the prediction about all of this evolution in the RAN, and in particular for Open RAN, is expecting to have like this 20 to 30% of the global market will be Open RAN by 2028. That today we expect to have something like 7 to 10% in 2024, But for the Open RAN, we're expecting to have like maybe between 20 and 30% by 2028. North America will lead the Open RAN market. Europe will see models based on revenue share uh, that will to see this model of Open RAN by 228. So far, we see that we are seeing like this single vendor Open RAN that is dominating so far. I mean, you see that we have like different players, but within these different players, so far like one single vendor is 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 having like this front face to the operator to offer this Open RAN solution. So, for example, when you see Samsung or Rakuten and all of that, there is like a strong player working with the operators, and supporting that single vendor. There are like all of these mix and match players supporting this Open RAN deployment. So, to the side of the operator, usually we see like only one player, but on the back on that single player, we have like these different players working for this single player. My major players like Ericsson and Nokia are participating in this Open RAN ecosystem. For example, you see like this Ericsson and agreement in the USA, and also you see, for example, in Europe or working of Samsung, Ericsson and Nokia playing all of this. Mavenir also like integrator is offering all of this service for Open RAN. This Open RAN enables new use case like autonomous vehicles, IoT, and mobile gaming. The virtual RAN also with this in particular for Open RAN is expected to run or to increase as you see like in the following years. For sure, there are several alliances all around the world for this promoting all of this or working all of this O-RAN. We have this O-RAN alliance that was founded in 2018 that has like over 30 operators, and we have like 300 contributors there. Yeah. So from these 300 players, some of them are focused on the academic. I mean, university also focus on this Open RAN. There's operators like also Chinese operators working on these, European, American operators, and most of the players here in these 300 contributors, we have providers. We have Nokia, we have Samsung, Huawei, sorry, not Huawei, Nokia, Ericsson, Mavenir, all of these involved over there. There is also Huawei is not here, and maybe you will see in some information around that Huawei is here in the Open RAN, but Huawei is not in the Open RAN Alliance so far. We have this small cell forum that is focused in the indoor or outdoor, but a small cell focus, like low output for RAN, working on this, working in the collaboration with the Open RAN Alliance or with the Open RAN team, the Linux Foundation, a non-profit organization working with the O-RAN Alliance to develop Open RAN software for the RAN, a Juniper Network and O-RAN that is also working here in the development of Open RAN. As you see, focus on non-proprietary subcomponents here. Telefonica, like operator, that is also working here in this like this global alliance. The Next-G Alliance, you know, they are focused on the deployment of 5G and future network future wireless technology that are working with the O-RAN Alliance. You see also alliance from the ETSI, European Telecommunication Standard, the 3GPP, that working together in collaboration with this ORAN, because there are some common component or also some specification that were taken from the 3GPP that are used here in the ORAN Alliance. As you see in the first slide, the specification 38801 that is using like the basic for this virtualization and cloudification ecosystem, and also for the ORAN that also are working in this collaboration, in particular for this specification for this virtualization or splitting possibilities. So in this Open RAN market, Open RAN market, you have like this. Let's gonna say just a few that put here. But if you see, as you see in the Open RAN Alliance page, you have 300 players. I just put here a few, but they are not all. So you have AWS, as you saw in the AWS case with this, that are providing cloud ecosystem for deployment and management of Open RAN networks. Ericsson here, Nokia, Next, NEC, like the players for Open RAN, because they have like a lot of experience, and also Samsung in the RAN. So they are participating here in this Open RAN. They have been incorporated in all of this work for defining standards, working together, PlugFest, where they test all of this integration between players. We have for the servers like this Fujitsu, Intel, HP that is working over there. And let's gonna say like new players that are working very good for this is the NVIDIA with all of these GPU processors working on this ecosystem for to accelerate for accelerating boards for the servers using these RAN sites. Red Hat that also have all of these cloud scenarios or cloud ecosystem for to be used for this virtualized with OpenStack and cloudified ecosystem with OpenShift solution to allow this working with the Open RAN. And also you have, let's gonna say, integrators that has some, let's gonna say, software, some parts of the software, and they put it together and offering this solution to operators like Mavenir and also entity data. So as you see here, you have different players in this Open RAN ecosystem working. Also, you have university here. Also, you have operator. So this one is just to show a little bit how are the players involved in this Open RAN. Anyway, if you go to the Open RAN Alliance, you will see more details about all the people involved in this work. In this slide, you see about a little bit about what the involvement or how was the traditional RAN and how is right now with the Open RAN in related to different aspects in the deployment of a site. For example, in the architecture, in the traditional RAN, we have only one provider. I mean, for site closed architecture from a single vendor. Usually, the operator they just have like maybe one or two players. I mean, per country, divided the country in regions. And so in each region, they have only one providers. Like, for example, in one region, they have, for example, Ericsson. In another part, they have Nokia. But with Open RAN, is open. It's a modular architecture, as you can see here, with interoperable components from multiple vendors. So you can have, like in one region, like let's say you can start from one provider to seven, to many providers, all of them working together. A vendor lock-in, as consequence of the previous information, in this one, you can have in per region like one player, and to change from one player to another player was kind of difficult because you have to change all of the components in that region. With the Open RAN, you try or you are focused on reduce that vendor lock-in. I mean, you have different vendors also in one region providing like these services. Focus on this mix and match component, like a little bit like a Lego, where you put together like different parts from different players and building your site. Customization. This customization was a little bit limited in traditional RAN because it was focused only on one player that you have to tell like your provider, like CTE, Huawei, Ericsson, whatever, please, I need this particular configuration or this particular specification for this site, and you have to talk directly with them. With the Open RAN, it's possible a higher customization because we're talking about cloudified, virtualized or a cloudified or virtualized scenarios where you can play a little bit with all of these. Let's want to say focus in particular for software where it's more flexible to work. So you can have with all of this ecosystem, the virtualized or in the cloudified solution, you have possibility to install XApp or our apps from different players and make like and play a little bit about that. For example, there is one player right now that I can remember that I was reading a little bit yesterday that is called Coherence. I think I can share that link in the video when they share this video in the YouTube channel from Asia Open RAN Academy. This particular software, they said that they can optimize the capacity of the site. So instead of increasing the capacity of the site in 1.5 on almost 2 times what was offering before. So I think it's something that very interesting, except that we have to check. At least we have to have in mind about what we can have. This is not just to have like player one providing all the solution but the interesting thing about this customization level is we can have like new players. Let's want to say, for example, this Coherence provider putting like this software in our RAN and providing like new solution that was not possible before. The cost on this one between traditional and Open RAN is higher CapEx and ongoing OpEx. The potential with this Open RAN is there is this potential for lower CapEx and OpEx because we are working with this disaggregation and this competition. We are talking about this, let's want to say this competition for around 300 players. So it's going to be like a very tough competition for all of them to offer the best solution from hardware or for software. Innovation, usually for the traditional RAN it has been a little bit, let's want to say, slower. But right now, because we have this virtualization and cloudification ecosystem, it's possible to offer a faster innovation to have enabling open interface and multi-vendor ecosystem. Performance is mature and stable performance because they have been for several years working on this RAN. And with this Open RAN, let's want to say from 2018, we're working on this Open RAN solution. So it's still maturing, but there is a potential for interoperability and new features integrated in the system. Deployments, longer deployments timeline and complex integrator. Right now, using this virtualization and cloudification possibilities, it's possible to have this faster deployment because everything is based on software, not in hardware. The ecosystem dominated by a few incumbent vendors. Before we say that we have like 3 or let's want to say 5 main players for RAN. Here we're talking about 300 players from the O-RAN Alliance. User case, we have optimized for generic mobile users. Right now is customized. We are players focused in small cell, players focused, for example, in rural areas other focus in this aerial transmission for airplanes and for small planes. So it's possible to offer like different kind of solutions. So with this, we can say, I think I will show you some additional information that I have after this one, but just to close a little bit here, is we have like this global adoption of Open RAN is accelerating around the world. Open RAN offers a more open, flexible, and interoperable approach. Could be a dominant force in telecommunications landscape. Also, it's possible that this Open RAN or something feature or at least principle of this could be used in the next generation, in 6 years, for examples. The operators they need to evaluate the different solution for them to include in the networks. It's expected Open RAN to have a key role in 6G and IoT applications. There are challenges here. For example, ensuring low latency, addressing a transport network and front haul requirements, because we have using right now this split in the stacks, managing different components in the networks. But it's possible working on this, or there is a potential for Open RANs with the collaboration of different operators, vendor, and industry bodies that will be crucial to expand the full potential of the Open RAN. So it's possible, all of this, providing innovation, improving customer experience, and shape the future of telecommunication. So I think this will be my last slides. Let me just show you here something. Global deployment. Okay, I think here, if you are interested in, for example, in this Open RAN split, you have here this. I think this one is a very good summary about all of this split in the Open RAN stack. As you see in here, you have like this split in this way, where you have like all of this layer that we saw before, like between RF, the physical layer, the MAC layer, the RLC layer, the PDCP, and the IP layer. So here we have like this specification for the RAN, let's want to say for the RAN stack. And for this RAN stack, it's possible to make like this split or this separation. The thing here is, as you go to the left here to this IP part here on the left, you need the latency, as you see here, could be high with no big impact. As you go here to the right, the latency is the requirements for latency are lower. So you have like different split. As you see here on the top, you have, for example, a split 1. If you split here, you have a split 2, 3, and all of that. And the particular that we use here in the Open RAN is the send.2x that is located here. And you have like this split here. So you can have a CU, DU in one part and RU in another part. Or if you use the double split that is called the 7.2x and the 2 split here, you have the CU unit, the DU unit, and the RU unit. That is the typical configuration for the RAN site under the ORAN specification. You have CU, DU, and RU, or you can have the CU and DU in one unit and the RU in another unit. For example, they use this CU DU unit in a cloud, for example, in a centralized cloud, or if you have like two clouds in the network, you can have like the CU in the centralized cloud when you have, for example, also the core parts, and this DU, for example, in a edge cloud, and you put RU in the remote. So this one, for example, will allow you like a flexibility because you don't have to install like the complete stack, the CU DU stack in the site. You handle all the resources in the core cloud or in the edge cloud with the CU and the U, and from there you connect to the RU in the site. The thing for this kind of configuration is you need like a very strong here front hall for this communication. So depending on the particular requirements, you can have all the sites deployed in the core, uh, and just the RU in the sites, or you can have this the distribution between core, edge, and sites to have the complete deployment.